Hello, class. So this week we learned about McDonald's burgers. We wanted to identify the reasons why McDonald's burgers don't mold nor decompose. We saw a picture in the article of a McDonald's burger on day one. On day 137, which is over half a year, the burger still remained pretty much the same. How is it that if we have a burger from In-N-Out, it tends to mold within a week? Yet we have a burger from McDonald's and half a year has passed and it hasn't decayed, it hasn't decomposed. Why is that the case? Well, it turns out that McDonald's doesn't simply just add chemicals, there's more to that. And it's actually quite simple. But before we do that, there's three questions I wanted to go over. What is decomposition? As you see on your screen, C turns into A plus B. We learned about decomposition reactions last year. Last semester, we learned about decomposition reactions where one thing turns into two or more things, right? So you have more of something at the very end. So the burger, why isn't it decomposing? Why isn't it forming other things like mold? And the second question, why don't McDonald's fries or burgers decompose? It's more than just adding chemicals. Their burgers do not have preservatives. So why do they still not decompose? And the reason why is because 50% of their burgers and fries are made purely of fat. There's very little very little moisture. There's almost no moisture on those patties. And because of that, nothing is going to survive, such as yeast or mold or anything like that. So when people eat burgers, the meat doesn't have anything that's nutriting you. It's not gonna give you anything good out of it. So that's why burgers don't decompose. They're all made out of a lot of fat, very little. Um, it's an environment where it an organism cannot survive. And the last question is how can we slow the rate at which something decomposes? So what would happen if we increase the temperature of the burger? Would that cause the burger to decompose over time? What would happen if we put it in a cold environment? Would that cause it to decompose over time? What would happen if we changed the pressure? We increased it, we decreased it. What would happen to it? So this is all science. We're trying to figure this out. And that's when people use the scientific method and they use controls and independent variables and dependent variables to figure these questions that we have. And the reason why I brought up the article, when I bring up articles, there's not just because I want to kill time, but it actually relates to the unit. So why don't burgers decompose? And this relates to the area or topic of kinetics. Kinetics is a study of how fast or how slow a reaction proceeds. In this case, why is it that McDonald's burgers decompose at a very extreme slow rate compared to a burger from In-N-Out where there's a fast rate of decomposition? Now that brings us to the next topic that we're going to talk about, and that is what are ways to impact the rate of a reaction. So rate means how fast or how slow. We are not talking about concentration, we are talking about a rate, miles per second, moles per second. How many moles of B is made in every minute? How many moles of C is used up per minute? That is what rates are. The first thing you need to know is the concentration of something affects rate. If you have A plus B makes C, so let's write this down. Let's say this is our reaction. A plus B makes C. Okay, so if you add more A and B to a reaction, you're going to make a lot of C. Okay, so the statement here says, as you increase, okay, so right here, as you increase the concentration, the rate of reaction increases, okay? So the more of something that you add, the higher the rate of the reaction. So the more A and B that you have, the more C you're going to make. So the second statement says, the higher the concentration, the more collision. So the more particles there are, the more they're colliding. And because they're colliding more, the chances that a chemical reaction will occur also goes up. Okay, so that's what happens when molecule A bounces onto molecule B. It's going to make something new, like molecule C. And the more collisions there are, the more A and B there is, the higher the reaction rate, the higher the chances that a reaction will occur. Okay? What is another thing that could increase the rate of a reaction besides concentration? It's temperature. As you heat up the molecules, they move faster. And because they move faster, the likelihood that they're going to collide with one another increases. And because of this, the reaction rate increases as well. So, here's another example. Let's say you have hydrogen gas molecules. They're going to react with oxygen gas molecules to form water. Okay, so this should be water. God, that's horrible. So water. Okay, so the more H2 and the more O2 molecules, the more likely that you're going to form water molecules. So the faster this happens as you keep adding these two guys. But now, what would happen if we increase the temperature? Well, if you increase the temperature, these molecules right here, they start moving faster and faster, and they're going to collide more. And because they collide more, you're going to increase the rate at which you make water. Okay? And point number 3. The last thing that could increase the reaction rate is something called pressure. As you increase the pressure, you're leaving less room for molecules to have, okay? Let's say you're in a classroom and the walls suddenly start moving inward. You're going to have less space. And because you have less space, you're going to be colliding more and more with the people around you. The same idea goes with molecules. The lower, let's say the balloon starts to shrink, the more the particles will collide with one another. And because they collide more, that's going to create a higher rate of reaction. So it's going to cause the molecules to actually bump into one another. And this is a chemical reaction, right? You're forming something new. And the last slide that I wanted to go over is this. On the left side of your notebook where you wrote your notes, I want you to summarize what I talked about on this podcast using the words I gave you. So, for example, kinetics is a study of how fast or slow a reaction proceeds. There are 3 factors that affect the reaction rate: pressure, temperature, and concentration. How do these 3 factors affect the rate at which something happens? And what do collisions have anything to do with reaction rates? So that is your last task. So on the left side of your notebook, make sure that you include all 5 terms. It would be great if you could underline them for me, so when I grade it, it will be easier to identify. And make sure you watch the video on EduCanon that talks about equilibrium. And make sure you jot down 7 key facts about the video. You want to know the 3 factors that affect reaction rates, and you also want to know what equilibrium is. That is the objective for today.